almost as soon as I made my commit last time, I realized that update level dimensions is a horrible design. That's a very bad interface. We have added this requirement on all of our child classes. So test level inherit from level data, right? We set up our tiles, we set up the tile layout, and then we have to call update level dimension in the base class to calculate the dimensions of our level. But there is no reason to calculate that. We don't need to store this. We don't like the information is available. We can just fetch it when someone asks for it. So I'll remove that call from the child class and go back to level data. And I'm just going to replace, like, so I want this. We can make a function, right? Function height equals tile size. Done. And then same thing for width. So whenever someone wants the width and height, we just return these values. We don't have to store them. Let's remove that. I think I have two members too, so I have to delete the variables because we don't need to store them. They're already stored. Tiles know its size, and the first row of our map also knows its size. So this makes much more sense. Okay, so we have an interface for for getting the sprite names, the bitmap resource names from tile IDs. Great. We have some way of storing them in some layout. We now need some form of LevelManager class to provide the service of loading within scare quotes. We're not loading at this point. We are hard coding this, but of loading these definitions, loading the bitmap, setting up the entities that we need, and then providing access to them for the game to use. So I'm going to name that horribly. I'm creating a new Kotlin class. I will just call it LevelManager for now. Because why not just call it level? Probably because level data and test level already contains that word, and I'm starting to get confused about sort of where is the level actually. I think level data is fairly fine, but whatever. So the level manager needs to take a level data object. So I'm going to call that a level. Oh, sorry, level data. Can I please type? There we go. Should I call that level or should I call that data? Maybe data. Okay, that's what it needs to do. And the first thing it does in its section is to load that level data. So load assets from that data set. Data or definition, perhaps. We can sort the naming out later. Now, we create that function because obviously that doesn't exist yet. Okay, we're going to load assets. These assets are generally going to be bitmaps, but I don't want to write bitmap loading code at the moment. I think what I will do is offload the bitmap loading code into the entities. We had bitmaps in the previous entities. Yeah, so we can reuse that. So what load assets will do is build a list of entities. Every tile will be an entity. And this will be somewhat wasteful, right? One of the benefits of having a tile-based engine is that we save a lot of memory. If you have 100 tiles with the same asset, you only need a single asset and then they can all reuse it. They use the same bitmap. If, on the other hand, we do what I am going to do now, that is, every entity has its own copy of that bitmap, we're obviously wasting some memory. However, we do the quick and dirty thing first to get our game up and running, and then we can come back and refactor. We want to have gameplay first. Like, shipping is a feature, so until performance becomes an issue, we don't have to concern ourselves too hard with it, right? And so in the later videos, we might come back and add like a bitmap pool so that all the entities are in fact reusing the same bitmaps. Or we have some other form of centralized storage so that a bitmap is only loaded once and then we pass it into the render function for each entity to draw as they see fit because they know their location and scale and so forth, right? There are many ways of going about that, but for now, to keep everything simple and let us reuse a lot of code, we shall create a list of entities. That's going to be our level in terms of what the game cares about. So private vol, let's call that entities, and it's an array list of entity. The standard library of Java still eludes me a little bit, so I just default to array list, and any linear container really is fine here, I'm pretty sure. We don't have the entity class, so let's open up the previous project and steal it, because we can reuse a lot of it. How do I do that? Let's see. Open. Platformer. No, my space shooter. In a new window. And then give me the folders. Thank you. Let's go to entity. Can I just take that? Right click, copy. And then in our new project, paste. Copy the file, keep the name, move to this directory. Yeah, that seems right. So we have an entity. Did it even update the package? That's amazing. Yeah, it seems so. Let's see, do we need to change anything here? Perhaps not yet. We have our interface for being able to address the different edges and the center of our entity. We have a very basic collision routine, that's fine. We will make our update loop time aware. So the interface for update might actually need a change. The way we usually do that is we pass in delta time. So the difference, how much time has passed since last time we called update? That's the delta time. Delta means difference. So whatever. We usually call that delta, and it's a float. That's the only change we need to make to this interface right now. This will allow us to scale our movements and our physics and everything else so that we are somewhat frame independent. It doesn't matter how often or how infrequent updates happen, we will always be able to scale motion for the amount of time that have elapsed, which will make the experience consistent across various devices. So delta time, it's a float. I think that's all we need. So we can go back to the level manager for now. We need to bring in entity. Oh yeah, that needs to be a construction too. Did you bring it in? Don't need to? Okay, you're good. So, okay, a list of entities. Cool, load assets are going to take care of that. But here's a bit of tip from one developer to another. A very common problem, a very common source of bugs for especially young, new developers of games is that you have your entity list and then you start adding gameplay features like falling out of the world and dying, running into enemies and dying, firing projectiles that need to disappear after some time or after they hit something. You have to add and remove stuff from your entity list all the time. And if you do that, as it happens in real time during an update, you will almost guaranteed run into crashes. The way you want to do this, to get around it easily, is to just keep two separate lists. Never change the length of your entity list during an update. You run all of the update first, and then at the end, you do a post-processing stage where you remove all of the dead entities and add any new entities. At the end of the frame, you are allowed to touch the entity list, but in between, never do that. So I'm going to add two new lists that are only here for keeping track of what needs to be added and what needs to be removed at the end of the frame. So one entities to add, and I'm going to copy paste this because I'm super lazy. And then that entire thing, entities to add, entities to remove. Okay? So if we wanted, we can do a bit of pseudocode here. We could provide an update function, right? It takes delta time for float as a float. I never told you what unit delta time is. The reason it's a float is because it is a fraction of a second. If your game runs at 60 frames per second, a frame generally lasts around 16 milliseconds. So you could pass in an int for the number of milliseconds that you've passed, but if we do a float, fraction of a second, we can use multiplication in most of our physics, and it becomes super easy to scale the velocities and motions using delta time straight up. So I prefer fractions of a second as the argument to our update loop. So we want to essentially update all entities. Actually, we can write that, can't we? How does Kotlin do that? Entities for each, see if I can fix this, sort out the syntax. Is it for each braces? And then you get the default argument, um, the default name of each object that you visit is it. So for each it, we call update and pass in delta time. We get rid of an entire loop by just writing this weird little syntax. But yeah, we visit every entity in the entities list, call update, pass in delta time. We are going to do some collision checking, probably. So we can, keep in the world. And lastly, we want to do sort of add and remove entities. So let's create add and remove entities. That doesn't exist, so we can create it. I do not understand why they feel the need to add this macro thing. Like, if you call this function while this is still here, your application crashes. But what's the benefit of that? Like, why can't I have an empty implementation? I wonder who that is intended to save. So this thing essentially just need to call, and we can use some clever array functions here. In fact, we can do entities. Let's see if remove all entities to remove. Is this Java 8? Is it Kotlin? I don't know, but it's very handy. I could have written a loop, but this just takes care of it. So take all the things inside of this list and remove it from this list. Perfect. Then we can call entities to remove, to remove and clear it. So we want it to be empty at the start of every frame. Similarly, entities add all, pass in the other collection, entities to add, and then we call entities to add, clear. So we update everything, and in these updates, we might end up adding stuff to entities to remove or entities to add. So we then call add and remove entities to do that in one fell swoop. First we remove, then we add. That also implies that we want methods to be able to add and remove entities. So we can have, let's call it add entity, because that makes sense. Pass in an entity. All it needs to do is entities to add. Is it add or is it push back? Jump between language, you get confused. So add entities adds to the temporary holding array, right? Until the end of the frame where they get added into the actual entities list. This will make your game far more robust. We want this to be remove entity. Entities to remove. So same thing here. When anyone wants to remove an entity, we just schedule that entity to be removed at the end of the frame. Okay, so back to this loading stuff. Load assets, where did it go? It's all the way at the bottom. That's fine. Okay, we need to loop over every index in our level data. So it's going to be a two-dimensional for loop. We probably want to figure out the height. Nah, let's just do this. For y, because that's a good, we want to be able to figure out what coordinates we're at. Y in 0, 2, and then we have, is it data? Data height, data width. It's height because it's the y-axis. And it is unhappy for reasons. Must have an iterator. What do you mean? Oh, no, for y in 0, 2. Until, it's not 2. There we go. So that gives us the Y position of this tile. We need the row, which we can get from data get row. We pass in the Y, and then for each X in 0 until that's row size. The tile ID should now be row X. And at this point, we can check if our tile ID is the null sprite, right? Why is that confused? Well, if it is, let's say if it isn't, right? Because if it is, we just want to call continue, which is a bit confusing. So I'm just going to go if it's not the null sprite, and then also figure out what's going on. Int and string. Is null sprite a string? Null sprite is a string. Let me go check the level data. What have I been thinking? No tile. I don't want the null sprite. The null sprite should absolutely be rendered. I want the no sprite. If there is no tile, don't position anything. Otherwise, we want to get the sprite name from the level data. So that would be level, kevel. Do I have, no, it's not, it's data. Hello. Get sprite name for tile ID. And at this point, we should be able to create an entity, I guess. So we want something like create an entity, passing in the sprite name, passing in X and Y. X and Y are going to be positions. What does the entity want for position? It wants floats. It's also not taking arguments, so we might have to fix that, but that's fine. Do I want to cast here? Do I want to cast in the next thing? We can convert those to floats here. And then we ask the editor, kindly generate another function for me. No. Show context. Create the function. I love that. That is so amazing. Except, of course, it was really confused about the naming here. So we want an X and a Y. So let me look at this. Step through every row of the level data, and then step through every column of that row to grab each tile, one column at a time, figure out the sprite name, create an entity for that sprite name. Okay. Whoop. Amen hello. Backa. There we go. So at this point, we need to create entities. We want to do something, if the sprite name equals the player, we want to create the player. If it's not, then we should make an empty entity of some other kind. We don't have any of those values yet. Let's see, if we do an entity, it's of type entity equals, let's see if I can figure out some Kotlin syntax. We branch on the sprite name, right? Open that. So if the sprite name is whatever value is in player, is it equals or the arrow operator? We'll see. I'm just going to create an empty entity. Can I do that? Does that want arguments? Is the syntax wrong? How is this supposed to go? Nope. Okay. Maybe not equals. Maybe it's that arrow. Empty entity. Otherwise, we can also just have an empty entity because we have no other classes at the moment. And then from this function, return the entity, I guess. Let's see what the complexity here is. Cannot create an instance of an abstract class. Of course. we need a player class. So this is going to have to be we need a future class here. So to do a player type, some static entity, because I think by default, if nothing else matches, we just want an entity that doesn't move, that's just part of the level geometry, sort of. But it seems the syntax is all right. It's just I don't have a type I can create yet. What about create entity? Because we're calling that and returning the thing. Should I be returning? Or should I just add? We can add them instead. So we call add entity, passing in our new thing. Okay, so double frustrating plumbing problem here, right? So we're still plumbing, we still have nothing we can test, and we don't even have the types we need to do the basic parsing yet. Let me just look at this class from top to bottom and see if I've thought about what I need to think about. We have a level manager. It takes a bit of level data. It calls load assets with that data. Let me go down there. For each row, for every column, get the ID from the level data, get the sprite name that ID is matched to, create that entity. That makes sense. We call add entity for each of those. Unless it's no tile, then we create nothing. Add entities adds to a waiting list. And then add and remove entities will happen during the first update, essentially, right? The first time update is called, it's going to be empty here, and then call add and remove entities. We could potentially call that at the end of load assets or at the end of init. Does it make sense to maybe do something like that? I think it does. That way we have all the entities ready before the core loop starts spinning. And from the game, if I just go back here, we should be able to have a private val level, which is a level manager, which takes an argument, and in this case, it's going to be test level. It's spelled with capital L. That makes sense. So we pass in the test level. This thing does its stuff. And then in our update function, which currently does not keep track of time, we're going to have to fix that. We should be able to call level update. We can just pass in something here, whatever. It doesn't matter. We'll go back and fix it. To do, calculate delta time properly. And then in our render call, we're going to have to ask the level for the entities list and do our thing there, because I don't think we want to leave that for the level to perform rendering. We'll see. I think we take a break here and then start looking at what our entities needs to be so we can get them on screen here. See you in a bit.